this video, I will do an example for the variance of linear combinations of two independent random variables. The question is a word problem and it goes like this. John plays a game with his friend in which a dime is tossed twice and a quarter is tossed 3 times. Very well. Then the question asks, find the variance of the total number of heads. Total number of heads means that, well, you get some number of heads on dime, some number of heads on quarter, add these two and you get the total number. The second part says if John wins $5 for each head on the dime and loses $2 for each head on the quarter, find the variance of the total amount of the money that John wins in this game. Very nice. So let us start setting up the problem first. Well, let's just choose some names for these random variables. What are the random variables? The number of heads on dime. Well, after twice the two toss we have, and number of heads on quarters. Well, you see that these guys are basically counting the number of heads, and well, if we define success to be heads, these are nothing but binomial random variable. This will be twice because the dime is tossed twice, and the rate that head comes out is half. And the other one is binomial random variable. This time we toss the quarters 3 times, and the chance that head on quarter comes up is half. So that's the first thing to note. And also you need to know that, well, for all values of x, and value b of y, you see the number of heads on dime and the number of heads on quarter, these guys are completely independent events. That's the whole point of tossing coin. Otherwise, well, if there were some dependence, then the world wouldn't work the way we expect now. So that means what? That means that these two guys, the events, and this are independent. For all, you see, A can be 0, 1, 2, B can be 0, 1, 2, and 3. In other words, the probability of x equal to A intersect y equals to B is equal to product of the probabilities. That's what independent events imply. But you see, when you write down this fact as you see here, right away you can conclude that x and y are independent. Nowhere in the question it is given. The only thing we know is the description of these ones, and based on the experiments, knowing the experiments, we know that now we can argue that x and y are independent random variables. So that's the first thing. Now let's go and try to solve the questions. Question 1 says, find the variance of the total number of heads. Well, what is total number of heads? Well, basically it says how many heads come on dime added to the number of heads from the quarter. So it means that basically we are trying to do this one, x plus y. And then we are trying to find the variance of x plus y, and we have to find that. In general, we know that there's no formula for this, but since x and y independent, we can use the famous formula. So this is 1 times x plus 1 times y, and this will give me 1 squared, a squared variance of x plus b squared variance of y. Very nice. Well, this basically gives me variance of x plus variance of y. But what are the variance of x and y? We know that x is binomial random variable b 2.5, and y is b 3.5. Remember this fact: variance of b and p is np1 minus p. And well, that tells me that here I have 2 times half times 1 minus half plus 3 times half 1 minus half. And in total, I get 2 times half plus 3 times half. And then when you add these guys, you get 2 over 4 plus 3 over 4, which is 5 over 4. So the variance of the total number of heads is equal to 5 over 4. That's part 1. Part 2 says something else. There is a different random variable, the amount of the money that John wins in this game. So let us just try to see what is this random variable. So this is part 2. The total amount money that John wins. So we know that for each head in dime, he gets $5. So X count the number of the heads on the dime, and for each head he gets 5. So you multiply 5 to that. And for each heads on the quarter Y, he loses $2. $2 losing, meaning that you for each one head on dime, you subtract -2 from the amount of money you win for the game. So the total amount of money that John wins is this random variable. Now we are trying to find variance of 5x minus 2y. Well, again, we will use the same formula. V of ax plus by is equal to a squared v of x plus b squared v of y. But this is only true when x and y are independent. Otherwise, this doesn't work. So when they are independent, which are in this case, we can do this. Here again, I have to mention this. You see the formula has this plus. So to be able to use the formula, I have to take 5 to be my x, but b to be -2. And since x and y are independent, so we are using this formula, 5 squared v of x plus -2 squared v of y. And this gives me 25 times vx plus 4vy. Vx, Vy we found in the previous example. Well, in the previous part, remember that the x is b2 1 over 2. So it's Vx was 2 over 4. And Vy is B3 half, and that's its variance. So it will be 3 over 4. And if you simplify this thing, basically, let me just write it as one piece. 4 50 plus 12. This is 72 over 4. Or in other words, this gives me very good number 18. So the variance of the total amount of money that John wins in this game is $18. And the number of heads, the variance is 5 over 2 heads. Again, this example, what was important was that we had to set up the random variables ourselves, and then see that these are independent random variables, and then go from there and do part 1 and part 2.